Hello. Today we're going to talk about Chapter 1, Section 5, Multiplying Polynomials. And multiplying polynomials, for the first few examples here, we're just going to be talking about the rules of exponents. When you multiply these are monomials because monomials contain only one term, but if you multiply two monomials and their bases are the same, you can see the bases are equal to x and the exponents are a and b. Well, if you multiply two monomials together with the same base, what you're going to get is you're going to get the same base x, and then what do you do with these exponents? You add them, a plus b. Now that would only work if the bases are the same. If this was an x and this is a y, then this rule doesn't hold. For example, if you're going to multiply y to the 7th times y to the negative 2, all you have to do is keep the base as a y and add 7 plus negative 2 and you get 5. Over here, sometimes the bases are numbers, not letters, so you have the base of 3, so you keep the base equal to 3, and then the exponents are just added together, so 4 plus 2 is 6, 3 to the 6. In the second example, you have this monomial called x to the a, and then this whole thing is raised up to the b power. So it's a little bit different than the previous example. It's called a power of a power. So you keep the base the same, the base is x, and you multiply those exponents, a times b. In this example here, you keep the base y, and now you multiply 4 times 3 and you get 12. And here the base is 5. Sometimes the bases are numbers. So you get 5 to the 2 times 3, which is 6. In this next example, you still have a monomial, but you have two factors within this monomial. You have a factor of x and y together. Each one of these two factors gets raised up to the power of a. So this becomes x to the a times y to the a. This a exponent actually gets applied to each one of these factors. This is a monomial made up of two factors. Let's put that in here. This xy is a monomial with two factors. So over here, when you have 3y, which is a monomial raised up to the third power, the 3 gets applied, this exponent gets applied to this 3, and also gets applied to this y. So you have 3 to the third times y to the third. And usually you don't leave it as 3 to the third. 3 to the third is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So this is actually 27y cubed. That would be the best way to express that answer. Over here, you have this 4 applied to the 2 and to the x and to the y and to the z because you have 4 factors within this monomial. So this becomes 2 to the 4th times x to the 4th times y to the 4th times z to the 4th. And usually, again, you don't leave it as 2 to the 4th because it's a small number. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this actually reduces down or simplifies down to 16x to the 4th, y to the 4th, z to the 4th. And that's how you should express your final answer. Now in this case here, this is x plus y or x minus y. I just put a plus or minus just to make it a little bit shorter. But this is not a monomial anymore. This is called a binomial. Binomials have two parts. When they're separated with a plus or a minus sign, this is a binomial with two terms. And when you square a binomial with two terms, you're actually not applying the 2 to the x and to the y like you did. These are completely different problems. What you have to do is do x plus y. If this was an x plus y squared, it's x plus y squared is equal to x plus y times x plus y. Or if you have x minus y squared, that's equal to x minus y times x minus y. And you remember from your other classes, this is a FOIL. Either one of these is a FOIL. So if you FOIL these out, you get x times x, which is x squared, x times y, which is xy, y times x, which is yx, but we'll just write it as xy, and y times y is y squared. And the only thing you can do here is you can combine these two terms in the middle together. Oops. Hopefully that's clear. And then this is x squared plus 2xy plus y squared. So x squared plus 2 times xy plus y squared would be what this would be simplified down to. And you would do the same thing here if you had x minus y squared. X times x again is x squared. And you have a negative xy and a negative xy, which reduces down to negative 2xy. And a negative y times a negative y is a positive y squared. So the two of those look pretty similar. The only difference is this is a positive middle term and this is a negative middle term. But the x squared and y squareds are both positive. So if you have x minus 4 squared, that's the same thing as x minus 4 times x minus 4. And when you FOIL this out, x squared minus 4x, negative 4 times negative 4 is positive 16. And these two middle terms combine, negative 4x and negative 4x combine to negative 8x plus 16. So there would be that example. Whoops, all boxed in. And then the last example, let's see if I can focus this a little bit better for you. There you go. Now the last example here is if you have these two monomials, this is a monomial, this is a monomial, they're multiplied together. It's not a binomial unless you have a plus or a minus in between them, but this is multiplication. So what you're going to do is C is any number and D is any number. So you're just going to multiply C times D together. So this becomes C times D. And then the x's, these x's are the same base, so x to the a times x to the b, just like in the top example here, becomes x to the a plus b. So the only difference between the top one and the bottom one is you have two numbers outside your variable here. So when you have an example like this, it should look like this. 5 times 6 is 30. And x to the 4th times x to the 7th, you add those two exponents, 4 plus 7 is 11. So that would be how that would simplify out. So what we're going to do right now is we're going to do just this left-hand column of odd numbers. So let's get started with this. And we'll leave this right-hand column of even numbers to do at a later time. So when you multiply these two together, I hope you're thinking through this before I'm actually explaining it to you, but you're going to be multiplying 2 times 7, which is kind of like this last example, which is 14. And now you have an a to the 5th times a to the 3rd, and you add the 5 plus 3 together and get 8. And then you have a b squared times a b squared, and adding the 2 plus 2 will give you 4. So there's your first example simplified down. The next one, number 3, if you square this, it's actually, well, you're actually squaring negative 3. I'm going to put that in parentheses because if you square a number, it becomes, no matter what, if it's negative or positive, it still becomes positive. And so this 2 gets applied to the negative 3, and it gets applied to the c to the 4th. And remember, c to the 4th to the 2nd power, that would be like this example up here. You're going to multiply the exponents because it's a power of a power. So that's c to the 8th. Now negative 3 times negative 3 is positive 9, so this becomes 9c to the 8th. This next example, this is a binomial. Here's a monomial times a binomial. Binomials have a subtraction sign in them. So what you're going to do is you're going to multiply this binomial, or this monomial, times the first term, and then you're going to multiply this monomial times the second term. This is just distributing. So you're distributing the 2x squared y into each one of these terms. 2x squared y times y will give you 2x squared times y, which is y squared. And then you have a minus, And now you're going to distribute this into the other term. So you have 2 times 2, which is 4. X squared doesn't have anything to match up with again. And y times y squared, you add the exponent. So there's an invisible 1 here. There's an invisible 1 here. So 1 plus 2 is equal to 3. So that would be the end of that problem. This next one is a FOIL. And if you've forgotten what FOIL means first, outer, inner, last. So the first term, 3x times x, is 3x to the second because you're adding those two exponents. 1 plus 1 is 2. And O for outside, 3 times negative 2 is negative 6, and then you have an x tacked on. The next one, I, is for inner. 1 times x is positive x. And then the last one is 1 times negative 2, which is just a negative 2. And then when you FOIL, you usually are able to combine the two middle terms. So you have 3x squared, a negative 6, and a positive 1 becomes a negative 5x, and then minus 2. So that would be the final answer for number 7. Number 9, if you are squaring a binomial, that would be like this example up here. A plus 3 to the second power, you're not going to just square the a and square the 3. You actually have to write this out, a plus 3 times a plus 3, because that's what squared means. Multiply it by itself. So this is a FOIL in disguise. A times a is a squared. A times 3 is 3a. 3 times a is another 3a. And 3 times 3 is 9. So FOIL. And with FOILs, usually the two middle terms will combine, the O and the I. So you have a squared plus 6a plus 9 is your final answer here. Now this next one is a little bit trickier. You have a binomial times a trinomial. And when you have a binomial times a trinomial, what you're going to do, there's a couple of ways that you can do this. Here's one way. You're going to take this 2x and you're going to distribute it into each one of these terms. So the 2x gets multiplied by the x squared and the x and the negative 5. And you'll write that out. And then you're going to take this 3, and the 3 gets also multiplied by the x squared and by the x and by the negative 5. So you're actually distributing two different terms into this trinomial. And we'll have some things that we're going to combine as like terms. So first of all, 2x times x squared. Well, the 2 stays a 2. X times x squared is x to the third. The next thing is we're going to multiply 2x times x, which is 2, and x times x is x squared. And now we're going to multiply 2x times negative 5. 2 times negative 5 is negative 10, and then we can't forget that x. Now that's the first part. And now we're going to distribute the 3, and I'm going to line these terms up to be underneath the like terms. So we have 3 times x squared, which is 3x squared. We have 3 times x, which is positive 3x. And then we have 3 times negative 5, which is negative 15. And I lined those up because now when I add these, I'm going to only add the like terms. So 2x cubed doesn't have anything to add to it. 2x squared plus 3x squared, if you remember, you're just going to add the coefficients and give that a 5x squared. The next thing is a negative 10x and a positive 3x will give you a negative 7x, and then a minus 15 doesn't have anything to combine with. So there's your final answer here. 4 terms. Whoops. Sorry about that. Hopefully you could get that. And now this next one, this last one, is our trickiest problem of all. So we'll go through this very carefully. 4y gets distributed to the 2y and to the negative 3. Now you have to be careful because this is like a negative 5 being distributed to the 2 and the negative y. So be careful of this minus here. It's really a negative sign. in front of the 5. So let's distribute 4y times 2y. Will you multiply 4 times 2 and get 8? Multiply 5, or y times y, and that's y squared. 4y times negative 3 is negative 12y. So that's the first thing distributed. Now we're going to distribute the negative 5 into this binomial. So negative 5 times positive 2 is negative 10. And negative 5 times negative y is a positive 5y. And the only other thing we can do now is we can combine the like terms, the negative 12y and the positive 5y. I'm going to put CLT because CLT should stand for combine like terms. You might have heard that phrase in earlier math classes, combine like terms. They both have a base of y and the exponent is the same. So that becomes 8y squared has nothing to combine with. A negative 12 and a positive 5 become a negative 7y. And then this negative 10 has nothing to combine with. So there would be your final answer for number 13. And if you have a multi-step problem, make sure you box in the answer at the end so it's very clear. And that's it for today. Have a great night.